This exam question tests your understanding of projectile motion. Let's get started. A boy kicks a soccer ball along level ground at 2 meters per second towards the edge of a small cliff, which is 9 meters high. Calculate the distance the soccer ball will land from the base of the vertical cliff face. Please pause the video here if you'd like to attempt this question before we cover the solution. Okay. As always, we just start by drawing a diagram of the situation. In this case, we have a cliff face which is 9 meters tall, and we can draw in a predicted trajectory off the cliff. Since air resistance was not stated in the question, we should write assume no air resistance just above our answer. The trick with this question is the ball initially has no vertical velocity. The only velocity present is our horizontal velocity along the level ground. Since we have no air resistance, the ball will sustain its initial velocity of 2 meters per second of horizontal velocity and gain vertical velocity due to gravity as it falls off the cliff. To start, we begin by determining the time taken for the ball to hit the ground. We can use S equals ut plus half at squared from our equation sheet. Sub in our vertical displacement as 9 meters and our acceleration due to gravity as 9.8 meters per second squared. We don't have any initial velocity, so this is going to be 0. We will solve this to find that the time taken to reach the ground is equal to 1.36 seconds. Since we know that the horizontal velocity does not change as there's no air resistance present, we can calculate the distance the ball lands from the cliff as time taken for the ball to hit the ground multiplied by the horizontal velocity of the ball, or S horizontal equals V horizontal multiplied by t. We can sub in V as 2 meters per second and t as 1.36 seconds. We can solve this to find that the ball lands 2.72 meters away from the cliff face. Thanks for watching. Check out our playlist on projectile motion exam questions for more worked solutions on this topic. See you next time.